Hello students, welcome back to the fifth video of this playlist. In this video, we will be solving question number 14 from the most recent past paper of Physics Unit 2, which is the October 2024 Unit 2 paper. So let's get started with question number 14 of this paper. Okay. Here we can see question number 14. So here it says, a student investigated the electrical properties of a light emitting diode, that is LED. Okay. He varied the potential difference, that is PD, across the LED and recorded corresponding values of the current in the LED. Okay. The graph shows the results. So we can see the current to voltage graph for an LED. Okay. So part A is asking here to draw a circuit diagram the student could use for this investigation. Okay. So basically, the student has varied the current, varied the potential difference, the PD across the LED. Okay. So for that, we should have a system in the circuit. We definitely we have idea about like how to draw a circuit, but we should keep in mind that uh, the LED, there should be a process to vary the PD across the LED. Okay, so let's draw the circuit. At first, the EMF source, the power supply. This is positive end of the power supply, and that's the negative end of the power supply. Okay, so this is the circuit goes like that way. Okay, so we need an emitter here. So we will connect an emitter there. So that would be the emitter. Okay, and then we should connect the diode, the light emitting diode, and we should vary the PD across it. Okay, so the symbol for LED, it's basically like this. If you consider, we should add a circle there. Okay, so the LED looks exactly like this. Remember the direction of LED, it should be towards this way. Okay, it should be pointed towards that way. So this is light emitting diode, so it is emitting light. Okay, and we should have a variable resistor. The work of the variable resistor is to vary the PD across the LED. Okay, so let's add a variable resistor there. So this will be the variable resistor. Okay, and this is connected to the emitter. Okay, so we need to have we need a voltmeter connected parallel to the diode to measure the PD across it, right? So this is basically the voltmeter. We should connect a voltmeter to measure the PD across the emitter, PD across the diode. So this is the voltmeter. Fine. So this is the circuit we can use, the student should use to for this investigation. Fine. Okay. Next is part B. In part B, the question says, determine the power of the LED when the PD across the LED was 2.2 volt. Okay. So we know that the formula for power, electrical power, so this is P equals to VI, where V is the PD across the component. So here the component is LED. So PD across the LED, it is 2.2 volt. So we need the current. So current we can find it from the current to voltage graph. Okay. So let's draw a dotted line at 2.2 volt, right? So 2.2 is basically here. So at 2.2 volt, if you draw a dotted line, it's basically intersecting at this point, which is 38 milliampere. Okay, this is 38 milliampere. Okay, so we got the current. current is 38 milliampere, and PD it is 2.2. So 2.2 times 38 milli is 10 inverse 3, that much volt. Okay, so the power, it's basically 2.2 times 38 times 10 inverse 3. So that would give you 209 over 2500. Sorry, it's not volt, it is basically watt. The power unit of power is watt, that much watt. So we can write it to fraction as 0. In decimal we can write 0.0836 watt. So power is 0.0836 watt, up to 3 significant figures, and that's the exact value. Fine. Okay, next is part C. In part C, the question says the student increased the PD across the LED from 0 volt to 2.4 volt. Describe without further calculations how the resistance of the LED changed. This is for 2 marks. Okay, so let's have a look on the graph, the I to V graph. So we can see that from 0 till 1.6 volt, is it 1.6 or 1.5? Yeah, 1.6 exactly. From 0 to 1.6 volt, the if you consider the gradient, basically the gradient of this graph, it is basically I over V, and we know that V equals to IR. So the I over V, it's basically 1 over R, the inverse of resistance, right? So we can see that from 0 to 1.6 volt, the ratio I over V, it is basically 0, right? That means the uh, the current was there. The current, if you consider the resistance R equals to V over I, isn't it? So that means there is a voltage from 0 to 1.6 volt, there is voltage, but there are no current. That means V over I, it is infinite. V over I, it is undefined, that is infinite. That means from 0 to 1.6 volt, the resistance of the LED, it is infinite. Okay, and after 1.6 volt, this is the first point, the resistance across the LED, it was infinite when the PD across the LED was 0 to uh, 1.6 volt. Okay, and after above 1.6 volt, when the PD across the LED was above 1.6 volt, we can see that there is a value for V to I ratio, right? But we can see that the I to V graph, it is basically increasing, isn't it? That means the resistance was decreasing for PD above 1.6 volt. That's the second point. Okay, so the first point, from 0 volt to 1.6 volt, the resistance of the LED was infinite, because V over I, there was a value for V, but I was 0. That's why infinite. Okay. Second point, above above 1.6 volt, the resistance of the LED has decreased. Okay, has decreased. Therefore, the current flow through the LED has increased. That's why. Okay, so above 1.6 volts, the resistance of the LED has decreased. That's how the resistance of LED has changed, as the PD across the LED has been changed from 0 volt to 2.4 volt. Fine.